How are you doing? So, I saw this. Let's take a look. I think there's a website for this too, but let's see. Play this. This is on Twitter, but there was a website for it too. So it's basically 2D rock paper scissors. So there's a bunch of things created: rocks, papers, and scissors. And if the papers get to the rock, they turn the rock into paper. If the scissors get to the paper, they turn the paper into scissors, and so forth. And so you can see at the end who wins. It's just kind of silly, but silly things are fun, right? And what's more fun than a silly thing is making the silly thing. And that's what I want to do. So I want to model this in Python, and I want to do it in 3D, not 2D. And I'm not gonna make scissors, but I will make balls and then move around. And so my idea, let's look at this one more time, because let me turn the volume off. I'm not gonna have sound. So it's kind of like if you're a scissor, then you're attracted to the paper. If you're a paper, you're repelled by the scissor. And it seems, I'm still not sure what's going on here, so I'm gonna make my own different one. So that paper is running away. But then if everything was equal, then it would catch. So I don't know if this is going to work. But we need to somehow model the interaction between rock, papers, and scissors. And of course, I'm going to use forces. And then we need to say, well, if they're close enough, then the winner changes. And it may or may not work. And I started building this, but I'm going to start over. So let's just get to it. Okay, I'm using Web VPython. You know that's what I like. Let's just make some spheres. Let's start off with some spheres, and they need to be random spheres. Okay, so you know the way I like to do things. I like to say n equals 0, n equals 10. So I'm going to make 10 objects. Is this big enough? Let's make it a little bigger. And then what I can do is say while n is less than n. And yes, there are better ways. There's always better ways to do things. But it's better to do it your way, the way that you understand. I think that's very intimidating when you start off with programming to say, well, I don't know the best elegant way to do that, so I'm not going to do it, or I'm going to Google it. If you do something like, I'm going to copy and paste something 10 times because that makes more sense to me, then that's what you should do. And I like to emphasize that every once in a while. So let's get going. And I do like to show my method here. So I'm going to print n, and then n equals n plus 1. So this is how I do a loop of 10 things, right? So if I run this, it'll just go 0 to 10 to 9. And that's what I want. Okay. Now, whenever I make these loops, I always put the n equals n plus 1 in there because I forget, and it'll go on forever. Now, what I want to do, I want to make my my rock, paper, scissors in a sphere, a distributed sphere of radius r. So let's just say it's 1. R equals, let's call it rs is equal to 1. That's the radius of my sphere. I'm going to need the mass of each one too, I think. M equals 1. I'm picking things. I'm going to need a constant, because I'm going to calculate the force between these based on some, it's like gravity, but I'll do 1 over r or something like that. So I need a constant there. Again, I'll call that 1. And I'm thinking ahead here that if I just have an attractive or repulsive force, things can get out of control when they get really close if I have 1 over r. And I don't want that. So I'm going to put a drag on there too. Drag that depends on the velocity, depends on the momentum. So c equals, you guessed it, 1. And we can change those. Okay. Now, one other thing. I'm going to make a bunch of spheres, but I don't want to give them names. I'm going to put them in a list. So I need a list. I'm going to call it my balls list, BS. And it's empty list. Okay. So the first thing I'm going to do is to make a bunch of spheres. So I want to make a random value between, I guess it'll be in a box, between negative 1, and 1. Negative R and R. Yeah, I'm thinking it'll just be a box. It won't be a sphere. That's fine. So let's just make that. So I'm going to make a random variable. I'm going to call it RT, and it's going to be R times the vector 2 times random minus 1, 2 times random minus 1, 2 times random minus 1. So I am using Web VPython. I said that already, which is not real Python. So the random function that I have is this random, and it returns a value between 0 and 1. So if I multiply that by 2, then it returns a value between 0 and 2. And then if I subtract 1, it returns a value between 1 and negative 1. So all of these will give a vector x-coordinate between negative 1 and 1, y between negative 1 and 1, z between negative 1 and 1. And that's just a vector. Now I'm going to make a sphere, and I'm going to add it to my list. So I'm going to say bs equals bs plus a list item, and if I put it in square brackets, it's going to include it as a list, and it's going to be a sphere. Its position is going to be that vector location. Its radius is going to be equal to, let's say, rs over 20, right? That's just going to be the size of the radius. Let's say this. Let's call it r is rs over 20. And let's call that just R. Then it's going to have a color. I don't really need that or anything right now. I think that should be fine. I've got a position and a radius, and let's run this and see what happens. Ooh. R. Why is it so big? RS divided by 20. Why are they so big? It's like they have a size of 1. 200 then. Oh, radius. Radius? Did I spell it wrong? Radius. 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 Sometimes you misspell things and you don't even notice it. They're still too big. I think they're a size of 1. Sphere. Position is RT. See if I get rid of that, I think it's going to be the same. No, didn't know that. So radius equals R. RS divided by 200. What the heck? 2000. It's the same. It's not. It's ignoring that. Oh, that's why. That should be RS. Got it. Okay, so there's my 10 random points, and it takes up a cube, and I'm pretty happy with that, and you can play it multiple times, and they're different. Okay, but now I want to give them all a type, and I want to give them a color. And so they're going to be either a rock, paper, or a scissor. So one of the nice things about Web VPython is that I can add different classes or different properties to this object sphere. So I can make my own property. I'm going to call it type. And so types are going to be either rock, paper, or scissor. So let's just say, but I need to pick what that is. Okay, so let's do this. Before we make our spheres, I want to make another random number. I'm going to call it R type. And it's going to be 3 times random. So it'll be between 0 and 3. And then so if the value is between 0 and 1, it'll be a rock. If the value is between 1 and 2, it'll be paper. And then if it's greater than 2, it'll be scissors. And they'll all have colors. So there's my thing. Now what I'm going to do, I'm going to say if type is less than 1, then it's a rock. So I'm going to say temporary type equals rock. And the color, T color, equals color dot yellow. So the rocks are yellow. How's that? Okay. And then I'm going to say if, oh, that should be T type or R type. If R type, and you can't even see that. That's crazy. If R type is greater than 1 and R type is less than 2. And yes, okay, what if it's actually 1? I don't care. If it's actually 1, that's never going to happen really. Exactly 1. right? Then it'll be like I don't know what happened. So if that's the case, then T type is going to be equal to paper, and that is a text. And then T color, the temporary color, is going to be color dot cyan. And then finally, if R type is greater than 2, then T type equals scissor. T color equals color dot magenta. Now, when I go down here to add my sphere, I can give it a type. Type equals T type. Color equals T color. Let's see what happens. Nothing. Can't find variable T type. T type. Where? Oh, T type. That's right. T type. Aha. That's why. Because I can't spell. Oh, and they're all. So something happened, I think. Color must be a vector. Okay, let's see. T color is color dot yellow. T color is color dot cyan. T color is color dot magenta. What did it not like about that? T color cyan, magenta. What did I do? T color. Okay. That's not working. That's fine. So we'll just go through and fix that. So let's not set the color here. I'm going to get rid of this. And it just doesn't like that. It could be a vector, and I could write it as a vector. Let's see if I do it this way. Oops, sorry. Okay, so now it didn't give them a color. Let's go through and set the color then. So after I made my list, I can go, this is one of my favorite Python list trick for B in BS. So it will go through the list of BS and call each element the name B. And then I can just say this, if B.type equals rock, then colon, B.color equals color.yellow. And then I'll say if B.type equals paper, colon, B.color equals color.cyan. If B.type equals scissor, colon, B.color equals color.magenta. Magenta. Okay, so that'll go through the whole list of all 10, and it should fix the colors. There we go. So there's my rock, paper, and scissors. The rocks are yellows, the paper is cyan, and the scissors are magenta. Okay, so now I also need to go through, I don't have, each object needs a mass, each object needs a momentum, we could use velocity, and each object needs a net force. And this is something that I learned when I'm dealing with multiple objects. I'm going to go through and give the net force as a property of that object, which is not, right? It's really a property of the interactions. But once I find all the forces on that object, I'm going to call it F. So let's do that down here. I'm already going through the thing. So I'm going to say B.m equals m. That's the mass. B.p equals vector 0, 0, 0. So it's going to start from rest. And then B.f equals vector 0, 0, 0. It's also starting at 0. I'm going to add that up. I'm going to change it, but I need something to change it to. Okay, so here's the part where I need to do something, right? I need to calculate the force on each object. So I'm going to go through and I'm going to go ahead and make this a function. I'm going to make a function that takes 2 points, 2 objects, and calculates the force between them. That way, when I go through my whole list, because if I have 10 items, if I have 10 numbers, I'm going to have to go through 100 calculations, right? Because each one I need to compare with each one to make see how they interact. So let's go ahead and make this as a function. So I'm going to put it up here. You don't actually have to do that, but I'm going to put it up here at the top. I'm going to say def f of p1, p2. So if you're not familiar with functions, I really like this way because it looks like a real function, f, capital F. And then what I'm going to do is give it 2 balls, P1 and P2, and I'm going to find the force on P1. That's what this is going to do. So let's put a comment. Finds force on P1 due to P2. That's how it's going to work. Okay, so the first thing I want to do is to find the vector from ball 1 to ball 2. Do I want to find ball 1 to ball 2? I want to find the vector on to ball 1. But I honestly already did this before, and I did it this way, and I don't want to mess it up. So I'm going to say RR, it's just a temporary vector. It's going to be P2.pos minus P1.pos, right? Because I need that vector between them so I can find the vector force. Now what I'm going to do is just make a whole bunch of calculations. The number one thing I'm going to say, if the magnitude of RR is less than 0.0001, I could say if it's equal to 0, but it's not going to be 0, because I have to deal with a couple cases, right? As I go through my list, I'm going to compare each ball with each ball in the same list, but it's going to compare it with itself. And so in that case, R is going to be 0. P1.pos minus P1.pos is 0. And so I should be able to say 0, but I'm scared because I don't know if there's going to be a rounding error or something like that, so I'm just going to say small. And that way also, if I have 2 different objects that are right on top of each other, there's no force either, because it could happen. So if that's the case, then I want to return the value of vector force, vector 0, 0, 0. No force, if that's the case. Okay, now I need to look at all the possible combinations, right? If P1 and P2 are the same type, if they're the same thing, I want no force between them because they're on the same team. So I can say if P1.type equals P2.type, then return no force, vector 0, 0, 0. Now, what if P1 is a rock and P2 is paper? Okay, so if that's the case, the rock, we're trying to find the force on the rock, it wants to get away. So let's say if P1.type equals rock and P2.type equals paper, then what do I want to do? I want to calculate the force and return it. It's going to be K times the vector divided by the magnitude of the distance between them, but I want it as a vector, so I'm going to include this norm RR. So that's a unit vector in the direction of R, divided by mag RR. So K is my constant and stuff like that. So there you go. Now, this is the force on R1. So it would repel, right? Because the rock wants to get away from the paper. It wants to get away. So that's pointing in the, I think, yeah, that is right. Final minus initial. I think that should be negative. Let's just do this. I think my calculations are wrong, but that's fine. I'm going to change this to P1.pos minus P2.pos. So now this is a repelling force on P1, right? Because it points, no. Because if the vector is from 2 to 1, yeah, it's repelling. That's what I want. Okay, if P1.type equals rock and P2.type equals scissor, then what do I return? Yeah. So in that case, I want it to be attracted. So I'm going to return the same thing, but I'm going to put a negative sign there. So it's going to be in the opposite direction. Negative K norm RR divided by mag RR. Now I just need to do all the other possible combinations. If P1.type equals paper, and P2.type equals rock. So let's just, I actually did all this. I'm not going to do it again. So let's just copy all of this, which I think I did weird. I'm going to copy the whole thing. I typed it up. I don't want to type this up. I typed it up, and I think I'm pretty happy with it. Including this. Okay. So this should work. One thing I noticed I did rock, rock, rock 3 times. And so I returned right here, if they're the same type, I give them 0. So I actually double do the type thing, but I just don't want to mess with that. I just want to get it to run. So, but this goes through and calculates the force on P1 due to P2. That's it. And there's a lot of stuff to do there because you have a lot of options. But that's all that does. Okay? Is that okay? That's okay. Okay, so where are we now? Now the next thing I want to do is to go ahead and let's just turn on time. I'm not going to have them battle. I just want to see if they can attract each other. This is going to go on forever. Okay, so this just makes all the stuff. This sets all the initial conditions. That is glow script, so I don't need that. Let's go down here and let's do something else. T equals 0. dt equals 0.01. So this is my time and my time step because I'm going to recalculate the force every 0.0 or 0.01 seconds. So let's do this. While t is less than 5. Let's run it for 5 seconds. Now I want this to be have a rate statement. Because I don't want this loop to run as fast as it can. I want it to go in a reasonable rate. And so since this is a time step of 0.01, this will do 100 of these loops per second if it can, and that's that. So the first thing I want to do is to calculate the force on each object, which I have a function to do that, but now I need to actually do that. So before I calculate the force, I need to set the force equal to 0. At the beginning of the time loop, I'm going to set all the forces equal to 0 and then go back and then add forces to that. So let's go do this. For B in BS, B.F equals vector 0, 0, 0. So that just resets the forces. Okay. Now watch this. For B1 in BS, for B2 in BS. So this goes through the loop BS, and it calls the element B1. And once it does that, it goes through the loop again and calls the element B2. So this will be 100 loops essentially. But now I can compare each item to each item in the list. And maybe this is an illegal move. I don't know. But I'm going to do it anyway. So first thing I'm going to do is calculate R. So it's a double loop. R is B2.pos minus B1.pos. And this is fine. Because I want to know. What do I want to know? Why do I need that? I don't think I do. I put it in my list before. I don't think I need this. I don't need to know the distance. I will need that. B1.pos minus B2.pos. Because when I get to the battle part, I need to know if they're overlapping or not. So now all I'm going to do is to calculate the force between B1 and B2, which I have a function for that, and add it to the total. Yep. So B1.f equals B1.f plus f B1, B2. So there's my function. That's going to calculate the force between them, and including type and everything, and add it to the force. And I'll go through and do the whole thing. So now I'll have the force on each element due to all the other elements. So that's a lot right there. Now I actually need to include drag. So that is just the force due to the interactions. So now I can say b1.f equals b1.f minus c times b1.p. So b1.p is the momentum. Minus c means it's going to be a drag force. And then so it won't keep speeding up forever, because as it goes faster and faster, that force is going to be greater until they balance. Now, different objects can go different speeds, right? Because if you have a greater force on it, then you're going to have a greater terminal velocity too. Okay, so what I did was to calculate, all it does is calculate the force. Now what I want to do is to update the momentum in the position. So let's do this again for B and BS. The first thing I need to do is to update the momentum. This is pretty easy. B.P equals B.P plus B.F times dt. Now I need to update the position. I'm looking over here what I did. I did some weird stuff before. Let's just update the position. B.POS is B.POS plus B.P times dt divided by B.M. And now I need to update time. T equals T plus dt. I didn't even save this stupid thing. Should I do that? 3D, rock, paper, scissors. Who's still watching this? I don't even know. I'm going to finish. If it takes all day, I probably won't because I'll run out of space or something. Okay, so let's run this and see what kind of disaster. Oh, they are moving. Okay, they're going a little fast. I did have over here a maximum speed. I have a drag force and a maximum speed. Okay, so let's do that the way I did it before, because it was kind of working. So I'm going to say Vm, the maximum speed I'm going to use is 0.02, so I won't let it go faster than that. So down here, after I update the momentum, I'm just going to say if the magnitude of B.P divided by M is greater than Vm, then I want to set the velocity equal to Vm. So B.P equals Vm times B.M. That's giving me the momentum times norm B.P. So I want it to go in the same direction. I just want to set the limiting speed. Okay, I think that'll work. Okay, so it's going slower. It looks better. Now, I'm looking for, are things attracted? Yeah, they are. Is anyone ever going to catch anyone? Let's change this time to 15 seconds. Is anybody going to catch? Anyone? So I'm looking at like this one right here. He's going towards, well, it's kind of hard. It's in 3D. Let's move it in 2D. So I can make everything in 2D by just changing this initial vector to 0 in the z direction. Now it's flat. There's better. Okay. So you'll notice here I have two scissors that are right on top of each other. They're not attracted or repelled. Now, are they going to catch this guy right there? I don't think anyone's ever catching anybody. So that's a problem right there. Okay. What could I do? See, I thought maybe like if you have two there, then the force would be, that'd be pulling it greater. Maybe I just need to let them go faster. Let's try this. Let's get rid of that maximum speed. I don't really like the maximum speed thing. So let's get rid of that. And let's slow it down by increasing the drag force to 10. Let's see if that helps. Okay, these two. Okay, there we got one. It caught it. Did you see that? Let's run this again. I'm looking for people to catch. See, these guys got separated because some of them were attracted over there and that guy was repelled. Okay. I think I kind of want to do, here, let's do this. Let's see if we can fix this. If the force is attractive or repulsive, so let's say, go back up to my force function right here. If the rock is attracted to the paper, no, it's repelled, so that's fine. Let's just put a factor in here. Let's say G equals 0.9. So if these are positive, I'm going to say G times, not that one, G times. G times. So it's a differential interaction. It attracts more than it repels. Oh, they caught. Okay, they're catching. So now all I need to do is do the battle. Okay, so let's make a battle function down here. I think I'm going to get this to work. Def battle. And it's going to take two objects, and it's going to do rock, paper, scissors. So it's going to take P1 and P2. And this plays rock, paper, scissors. So what I want to do is to look at the two types. I just have a couple options, right? So let's say if P1.type equals rock and P2.type equals paper, then what happens? And this is just, yeah, it doesn't really matter. I'm gonna return both objects. I think I can just change it, not return anything. I think so. Let's see. Okay. So if that's true, then no. Let's return two types, and then we'll change it. Okay. So if that's true, then return type for P1 will be paper. This is to return paper, paper. They're both paper. If P1.type equals rock, rocks, and P2.type equals scissor, then return rock, rock. Rock beats scissors, yeah. Rock, rock. And then if P1.type equals rock and P2.type equals rock, rock. Return rock, rock. Okay. Now, do I need to do that for, so I have rock versus paper. I got that. I need to do paper, paper, scissors, scissors. And I think I'm done. Oops. Let's just copy this. Oops. Dedent this. So this is do scissor, scissor. And then return scissor, scissor. And then let's do it one more time for paper, paper. Paper, copy, paste, paste. Not our paper. That would totally mess me up right there. Do you see what I just did? I saved it. Okay, so now down here, I have my R. Let's do this at the beginning. Did I put it in there or did I take it out? 4B, where's my R? Oh, let's do R up here. Let's do it at the beginning of the loop. So R equals B1, no, I can't do it right there. Or I did it right here. Okay, so let's do it right here. Let's say battle no, T1, T2 equals battle B1, B2. This is going to be a battle between T1 and T2. And I'm going to return the values as T1 and T2. Now all I have to do is reset them. So I'm going to say T B1.type equals T1, B2.type equals T2. Now I do need to reset the colors. So I'm going to do that up here. I'll do that at the end. Up here. So I already go through the whole list right here. So let's just fix the colors, which I didn't do before. So that needs to be in. Oh, it's all messed up. Tab, oops, tab. And then this needs to be tabbed. Okay. Is that going to work? Who the heck knows? I'm not going to do this forever. It's going to be my longest video ever. But let's just see. They're not moving. Undefined object iterable. Undefined is not an object. Let's see. Battle. I did do def battle, right? Def battle. P1, P2. It should, let's just try this. After I make my objects, where do I go through? Here's my objects. So let's just print, let's just try this. Print battle B0, B1. And it should print two types. It should, if it gets that far. It didn't. Okay, P1.type. P1.type. It says that doesn't exist, I guess. Let's see. Let's just try this. Print B0.type. It didn't do that. Oh boy. I could have used numbers, I guess. Okay. If P1.type is rock, it's working up there before with the type. Okay, so B, R type, type, T type. Type. It's right there. Does it not like that word type? So right here, let's try it. I just made some things with some types. So print BS. BS0.type. It's not B. This is BS. That did work. Okay, good. Whew. Okay, so now let's try the battle. Where'd I have that? So I have stuff. I can do a battle. Let's do battle. Print battle BS0 BS1. Let's see what it prints out. Oh, not print. Print battle BS0 BS1. Okay, let's see. It did. It printed out rock. Let's try changing. So now, let's say T1. Oh, I need to do it like this. Where to put my battle? I think I need to do this. Oh, how about this? T, and then let's call this T0 and T1. That's going to do it. It's going to return a list of things, and I need the first one and the second one. Got it. But I can't use T because that's time. So let's do TTT. TTTT. TTT. I think I might add TT also. Okay. I think it's going to work. No. B1. TTT. Let's just print that TTT. Let's see if it gets there. Scissor, scissor. Okay. But then it prints undefined. Let's print B1.type. Print C. So it did it. So where's the undefined coming from? So it's doing that. It's printing that. I wonder if it's down here. For b.type equals rock, b.color. That's fine. That should change. Let's just try commenting out all this. I don't think that's the error. Paper. So it's somewhere down here, b1.type. Did it print this? Did I print the type after I said it? I think I did. Print b1.type. Let's do 2. Print b2.type. Paper. Where's the undefined coming from? It's printing something after that. Print. Where is it printing? Maybe it's this. Maybe it's coming back through the loop and printing. Okay, I am going to end this, and then I will see if I can fix it later, because I can't go on forever. But you get the idea. Partial failure. I'll talk to you later.